How are you doing? Good morning, grade 7, math 7. I'm super excited to be with you guys. I'm hoping everybody's healthy, and I hope you're enjoying this good weather, but just staying outside with masks and just doing your best just to stay sane as well. As we continue in this unit of statistics and probability, or rather not probability, but experimental probability, I believe we're on right now. Or no, we're not on experimental. I'm jumping ahead of myself because that's where we're going. We're talking about analyzing, comparing data, and we're going into experimenting probability. This is the last lesson in this unit. We're going to do this lesson today, and we're going to do a little bit of practice in it. And then from there, we're going to dive into the experimental probability, okay? So let's look at the worksheet that is attached to today's lesson, okay? So we're going to be talking about mean and mad, and I like calling it that because, well, when people are mean, sometimes they are mad, right? But in particular, we're going to talk about mean, calculating the average, which we already done before, as well as something called mad, which we haven't looked at, and that's why this lesson is an intro as well as a practice of calculating mad, and then we're going to do some comparing of different data regarding variabilities with that. So we're going to calculate mad as well as talk about what does variability really mean and why does that connect with MAD in itself. MAD stands for mean absolute deviation. Let's start off by just looking at the bell work for now, and then I'll break down the understanding of MAD in a little bit. Bell work says to calculate the mean of these two data sets. Now, you know how to calculate the mean. The mean is the average. So do me a favor and see if you can calculate the mean of both A and B. You can pause the video here. That way I don't give you the answer. All right, so I'm hoping that you had a chance to calculate the mean. Let me go through it with you. So, and when we calculate the mean, just so everybody's on the same page, you can use your calculator. I'm hoping that you have with you, or you can use your phone, which is also, you can open the calculator app on there. To calculate the mean, we need to add up all the data points. So we have 9 plus 16 plus 13 plus 14 plus 10 plus 16 plus 17 plus 9. Now, when you add those all up, you get 104, right? That all of this adds up to give you 104. I just want to write it down. That way, if somebody's looking at it and just to check their work. Okay. When you add this all up together, oops, sorry, you get 104. Right? That gives you 104. Now, in order to find the mean, you need to divide that 104 by the total amount of numbers here present. So if you look at the numbers, there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers in total. So we're going to take that 104, and we're going to divide that by 8. And when you divide that by 8, you end up with 13. So if you got 13 for the mean here, you got it correct. Let's look at B as well quickly. We do 108 plus 95 plus 104 plus 96 plus 97 plus 106 plus 94. So you should get a total of 700 when you add all these numbers together. So when you add all these numbers together, you should have got 700. Now this is 0 and another 0. Should have got 700. Now, we need to divide the 700 by the total amount of numbers here, and you'll see that there's a total of 7 numbers, which means our mean for this particular data set is 100. I'm sorry, it's lagging a little bit. Hopefully it gets a little better, okay? So that's our mean for A, 13, our mean for B, 100, okay? And it's the average of all the numbers that we got, and you can kind of see that in both of these, that 13 is in the middle of all these numbers, and 100 is kind of in the middle of all these numbers. It's the average of all the numbers, right? Our essential question that we're going to be focusing on today is, how can you use statistical measures, meaning mean and MAD, right? Those are our two statistical measures to compare populations. So we talked about populations at the beginning of the last unit, actually. And populations are a set of people or something that we're observing and looking at. It could be the squirrel population in New York. It could be how many pencils are in a school, right? Any type of population that we're looking at is the area of focus of observation. But how can we use these two data values, these two measuring sticks of some sort, to analyze data. So mean and MAD are two statistical measures that we can use to compare different populations. So we can use them to talk about different aspects of populations. But before we talk about how we can use those, I need to talk about what is MAD. What is this MAD and how do we calculate it? We know how to calculate mean, but how do we calculate MAD? MAD stands for mean absolute deviation. The mean absolute deviation of a data set is the average distance between each data point and the mean. All right, so for example, we can look up here, and we just found out for B, right, looking at the bell work, that the mean, right, I'm just gonna write it here, the mean we talked about, oh, sorry, right, we talked about the mean. Sorry here, right, we said the mean was 100, right? We can look and say, okay, 100, but if you look at the data point, one data point is 108. 108 and 100, there's a difference between those data points. So the mean absolute deviation is talking about the average distance between each data point and the mean. So if you look, there's a distance of 8 points there, right? There's a distance here of about 5, a distance here about 4, a distance there about 4, distance here about 3, distance there about 6, distance here about 6. Right, so you can see that there's distances between each one of the data points and the actual mean. The mean absolute deviation is talking about that distance. It's talking about the distance between the data and the mean itself. And it gives us this idea of variability. How varied is the data? You can see that this one is 8 pieces away, 5 pieces away, 4 pieces away, 4 pieces away, 3 pieces, right? So there's this distance that we can recognize. What is the actual mean of that distance is what we want to find. What is the mean of the distance? What is the average distance between the data value and the mean? That's what we want to find. And that makes it where we'll find the variability in the data, how far it's actually away. So let's dive further into understanding mean, MAD a little bit further. And then what we'll do is I'll do a modeling example of what I want you to do today. And then you can continue to work on it. So let's break down MAD just a little bit. Now, M stands for mean, right? We all know that M stands for mean in this, and we should be okay with that because we know what mean is, right? Mean is the average, right? Right, mean is the average. So mean is the average of the data. So we add every data point up, we divide it by 3, right? So 4 plus 5 plus 6 is 15. Divide that by 3, we get 5. Okay? A in MAD stands for absolute, right? This is our absolute. Now, I'm waiting on the marker to actually stay with me. Right? Stands for absolute. We should recognize that as absolute value, right? Well, why are we using absolute value? Because absolute value is essential here for us to find the distance between the original data point and the mean, right? So for example, if you had a negative number, like in this example here, 4 minus 5, right, which is the original data point here, 4 minus 5, which is the mean, we get -1. But we need to find the absolute value of that. What is the actual distance from the original data and the mean? And that's really just one space. Even though it's a -1, take the absolute value, we get +1. And then D in this particular MAD breakdown stands for deviation. And this is a fairly new word, but if you go into further math, it'll pop out a little bit more to you because you'll see this a whole lot, right? Deviation really means change, right? It's the change that's occurring here. So the original was 4. The change that really is happening is 1 space. That's that absolute value. It's only 1 space difference, which got us to 5. Right? It's not, now we do need to find the actual average of all these changes, right? Once we find the average of all the changes, like here, the mean, we'll find the MAD. All right, so let me break down and show you what that looks like in terms of us calculating so you can work on that on your own as well, okay? Now there is a homework section as well as a pair share section. All you gotta do is complete 2 of them, whether it's 2 of the homework ones or 2 of the pair share ones, just complete 2 of them and put them up, okay? So I'm going to clear this, and then I'm going to show you the modeling. Okay. All right. Okay, no problem. So if we're given a data set as 3, 7, 8, and all the data sets I gave you further on are a lot more numbers than this. 7, I think, is the max, or 9 is the max, or 7, I think, is the max, actually. 7 is the max. But let's say we have a group of 3, 7, and 8, right? First thing we need to do is I made a chart for you to try to break down what's happening in your mind to get you to these answers, okay? So follow with me. It's not hard. It's not complicated as one of the last lessons we did, but it is still time consuming for you to make sure you don't mess up. If you mess up with any area here, your actual mean absolute deviation may be incorrect, okay? So the data. First, we're going to write down the data that we have here. So what is the data that we have? What's the data that we're looking at? We have 3 numbers. We have 3. Let's see, is it working here? Nope, it's moving the actual chart. Let's try this one more time. We have 3, 7, and 8. What is the mean? So we would calculate the mean of this data. So the mean is 3 plus 7, which is 10. 10 plus 8 is 18. So that's 18, but then we have to find the mean, which means we have to divide that by 3. So what is 18 divided by 3? We get 6. Okay? I'm going to break this down for you one more time. 3 plus 7 plus 8 gives us 18. Right? 18 divided by 3, because there are 3 numbers here. 1, 2, 3. 18 divided by 3, that's what gives us our 6. So this mean is 6. The mean is 6 for all of them, because we know that's the mean, period. Okay? What is the difference? Now, what does it mean to calculate the difference here? We want to figure out, well, what's the difference between the data and the mean? So we're going to do the data minus the mean. 3 minus 6. Oh, hold on. This thing started doing something a little weird there with that 6. Well, Mr. Woodford, does it matter if I do the data minus the mean or if I did the mean minus the data? It does not matter. Let me explain why. 3 minus 6 is going to give us a negative 3. 6 minus 3 is going to give us a positive 3. When it's said and done, we still need to do the absolute value, so they're all going to end up being positive. So no matter what difference you decide to do, if you did the mean minus data, or if you did data minus mean, either one is going to end up giving us a value that we're going to use in the absolute value. All right, so it doesn't matter which one you would did. If you did data minus mean or mean minus data, it does not matter. I am doing data minus mean, though, just so we're all on the same page. Okay, we got 3 minus 6, that is negative 3. Okay, we got 7 minus 6, that's 1. And then we got 8 minus 6, and that is 2. Okay, now we do need to do the absolute value of these numbers. So what's the absolute value of negative 3? I said it before, it's just going to be a positive 3. What's the absolute value of 1? Absolute value of 1 is 1. What's the absolute value of 2? That's 2. And just to refresh our memory, absolute value means the distance from 0. How far is this number from 0? We know that negative 3 is 3 spaces from 0. That's why it's a positive 3. Okay? Now, let's do the sum. What does the word sum mean? That means to add them all together. If you need to write this down, right? Add together. Add together, okay? Okay, so when we do 3 plus 1 plus 2, we end up getting 6. So the sum is 6. How many numbers are there total? There are 3 numbers. Right? That's what the count means. We add these up, we get 3 plus 1 plus 2, that gives us 6. What is the count of the actual numbers? There are 3 numbers here. 3 numbers. 1, 2, 3. So if there was a total of 3 data points, there's going to be a count of 3. If there was 5 data points, there's going to be a count of 5. Okay? So now we have the sum, we have the count, and now we need to find the mean absolute deviation, which is just finding the average of all the changes. So since the change of 3, 1, and 2, we're going to take the 6 divided by 3. Our mean absolute value is going to be 2. Oh, sorry. Our mean absolute value is going to be 2. Okay. Oh. Okay. So our mean absolute value here is 2. That is our answer. Right? That's what we're looking for. We're looking for this mean absolute value. Now, we're going to go further into comparing the mean and the mean absolute value of data to find the variability. And variability simply means the change in the data, right? How far is the data changing? How far is it varying? So in this case here, you can see that to go from the mean, the mean, which is 6, and the data here, which is 3, there's a change or variability of 3. However, you can see from 7 to 6, the data being 7, the mean being 6, there's only a 1 data that variable. There's only a movement of 1 space, as well as this one moving 2. So the data is varying by average, honestly, of 2 spaces. So if we take this 3 plus 1 plus 2, we can say, okay, the average in terms of the movement of the data is about 2 spaces, okay? Do me a favor, please complete 2 other following. Either it's 2 of the pair practice, or you complete the 2 homework ones, or you can do a mismatch of either one. But please take your time to complete 2 of them. That way you could get a better understanding of how to calculate the mean absolute deviation, okay? I look forward to seeing your work. You guys have an incredible day. I will talk to you soon, okay? Thank you guys so much. Oh, as I told my 8th graders, I'm probably going to try to plan a field trip, which is weird. It's going to be like a Zoom video where you could connect to the Zoom. I'll be outside. You could be outside in your own backyard or somewhere, and we'll try to create some games that we're doing via internet. That way, we're still able to engage with one another and have a little bit of fun. All right? Talk to you guys later. Have a great day. Bye-bye.